Hello everyone. Welcome to this video presentation on RC circuit. So the simulation is based on a low pass RC circuit. This is experiment 2. So here you could already see the circuit is drawn. I would be showing you how have I drawn it. It's there's a two-part of the experiment. First of all, we have this low pass RC circuit, and next we have high pass RC circuit. So low pass RC circuit is already drawn, and I would show you how I've drawn the circuit in the next part of the experiment, where the design of this diagram is pretty similar. It's just the interchange of the resistor and the capacitor. So for the high pass circuit, I would show you how the elements has been assembled. So here you could see that it is 2 volt peak-to-peak voltage. I just mentioned the specifications for the first part of the experiment. We have R as 1 kilo ohm and C as 0.1 microfarad, and VIN input voltage is 2 volt PPP, peak-to-peak voltage, and 1 kilohertz frequency. So it's a 2 volt peak-to-peak voltage, or you can say for us here, here we have taken 1 volt peak voltage. So that way also we can do. So now I just want to show you what are the things I've incorporated here. So first I have taken the AC voltage from here, and I've mentioned the specifications accordingly. As you could see here, when I'm clicking on it, you could check all the specifications over here. So instead of V1, we can always make it to VIN. And then the already specified values as given in the experiment. Then we move on to the register. This I've taken from the library of the passive elements that you could see here. This one. And then we have we are taking the voltage probe for register and the reference voltage also. I showed you last time. So this is the reference voltage. So that we are measuring the voltage across resistor only. Then we have capacitor. Here this would I have written in VC, but if you want to have a parity with our experimental diagram. And this is with respect to V out would be with respect to ground, and so we would be measuring VR and V out. Okay, so here you can change the color. I forgotten to show it maybe in the last lecture, I believe. So here you could see here you can change the color. If by default the probe color would be fluorescent green. So if you want to change it, you have to select color from here, and accordingly would be your plot in the final schematic, in the final graphical schematic. Okay. So then we can after designing this, you have to you can there's one more thing I just forgot to mention. When you're assembling the elements, you have to mention the specified values. You can use the bar for over here. Here also you could use. When you click on the specified element, it would help you to adjust its magnitude. And the same thing you can do it for the capacitor as well. Here I have you can do it here manually, or you can adjust it with the slider. Okay. When you click on here, you can adjust. When you click on here, you can adjust the value manually. Okay. So next, you have to select from here. Here we have 2 parts: transient and AC sweep. Okay. So if this is an AC input, so you can plot it in both ways. Suppose we are doing it for transient, so you can see the simulation. And next we would go for the AC sweep. So this would be your transient voltage plot. You can split it if you want. So you can have the schematic on one side, and you can have your graphs, your graphical plot on the other side, and thereby you have to adjust the schematic so that it come in the same window. Okay. So next you move on to AC sweep. So here you simulate again. So here you would get the magnitude and the phase plot. Okay. So accordingly, see the plots, the way the plots, the colors of the plots, or the line width of the plots. You have to adjust it accordingly in your schematic, and that will be reflected over here. So next we will design the hypersphere. So it's nothing. It's just you take this out. I'm sorry. I just made a mistake. Let's undo this part. So what we can do here is make a copy of it. Keep it. Okay. And similarly, we're making a copy of it, and we're keeping it aside. Okay. Then you delete this one as well. And if you want, you can delete the voltage references because we have to reassign them. Okay, so let's delete this, and let's check the specifications. So it's just the interchange of the resistor and capacitor. Okay, and we're using the same value, so we don't need to alter the given magnitudes of the elements. Okay. So you just make a tilt, 90-degree tilt, and then copy it over here and place it over here. We would adjust it likewise such that the probe is aligned and we don't have to do much rework. So next we would be joining the wires. So next we would be incorporating probes. So you have to set the reference voltage over here, otherwise it won't be taken. Otherwise, by default, it is the voltage. All the voltages are measured with respect to the ground. Okay. Then on selecting this, you have to change the color. Otherwise, both these colors are pretty much similar. It's not very well perceptive for distinction. So you can change this. I think it would be sufficient to measure the output voltage only, but I'm showing you in a bit detail. So accordingly, you check what is required for the measurements, for the calculation steps. You check what you need to show in the report, and thereby you can proceed with it. I'm showing you in a bit detail. Okay. So then we're all set. So let's check transient first. Next you can see the AC suite, where you have the magnitude and the phase plot. So you can see here that these are the specific. It's the range of the phase that has been taken. If you want, you can take it from -180 to +180. Okay, and the same thing you can do for the logarithmic scale as well. Okay, you can change it here in case you want it to be the dB scale. Okay, so for both the case, for high pass filter, you can do the same thing for low pass filter as well. So I guess that's all for today. Thank you for attending. Thanks so much.